The objective of this experiment: first, to study the properties of gases; second, to study the effects of pressure and also temperature; and the third, to explore the Boyle's law and also Charles' law.
First of all, for part A, we need to change the SI unit for temperature from Kelvin to degree Celsius, and then click and drag the pump handle and pump the particle 2 times into the chamber. Next, the temperature is adjusted at room temperature, which is at 20 to 7 degrees Celsius, and click the hold constant for temperature. Next, click the collision counter and with slowly increase the volume and see the pressure. Then I add another 0.5 nanometer for volume, and the pressure shows that decreasing. First of all, click the collision counter and with to show the volume of the chamber. Next, for part B, click and drag the pump handle and pump the particles 2 times into the chamber. Next step is click the hold constant for pressure, and the pressure shows is 11.7 atm. Next is slowly increase the temperature. Before that, change the SI unit of temperature Kelvin to degree Celsius. Slowly increase the temperature and the volume also increases. First of all, as usual, click the collision counter and the width. Then click and drag the handle and pump the particles 2 times into the chamber. Next step is click the hold constant for volume, which is it will remain constant, 10 nanometer for the volume for this chamber. Next, slowly increase before that, change the SI unit for temperature from Kelvin to degree Celsius, and then slowly increase the temperature and observe the changes of pressure. So here we can see as the temperature increases, the pressure also increases. Last but not least, for the result section, here we can see it in 3 aspects, which is in part A, part B, and part C. For part A observation, I can say that when the volume is increases, the pressure is decreases, while for part B, when the temperature is increases, the volume also increases and also increases. And the last part is part C, when the temperature increases, the pressure also increases.
Discussion. In this experiment, with testing Boyle's law P1 V1 equal to P2 V2 and figure out when the number of molecules is double in the gas with constant volume, pressure is increased. It is because the frequency of collides with each other and the wall is higher. The higher the frequency of colliding between each other and wall, the higher the pressure in the chamber. For the second part, when decrease the volume of the chamber, less molecule travel and increase collision frequency, and thus pressure increase and follow Charles' law V1 over T1 equal to V2 over T2 because temperature was not maintained constant. We can use the simplified PV equal to nRT where volume decrease making pressure increase, resulting in the required temperature increase.
Conclusion. In a nutshell, the properties of gas are they have no fixed shape and fixed volume. Those properties of gas is always depends on the pressure, volume and also temperature. Those three factors always affecting one on another. Based on Boyle's law, when the volume of the chamber decreased, the collision frequency among the air particles increased and thus the pressure also increased. Moreover, based on the Charles' law, when the temperature increased, the collision frequency increased and the pressure also increased. As an example of Boyle's law, when the bubble grows towards the surface of the water, as the pressure of higher water decreases, it's increase in size. Moreover, Charles' law has shown that variations in temperature will decide the amount of a gas. This law is very important because gases are also used in plethora of power generation applications nowadays.